Hi class, I'm here to talk to you about sedimentary rocks, a little bit about weathering and the processes that cause the formation of sediments, as well as the process of lithification. In this slide on the left, or on the image on the left, you can see layers or beds of sedimentary rock. We'll talk about how those form. And then at the bottom, you can see that this rock's actually weathering, falling apart, and creating a very similar sediment down below, which may eventually turn into a sedimentary rock yet again. This is part of the rock cycle. This rock here is breaking down through physical and chemical processes to create these loose sediments, which can then go back into the lithification cycle. Questions to think about or consider, as usual: how are rocks classified? How are sedimentary rocks classified in this chapter? How are they formed? Where do the rocks form? And how do we interpret their origins? So what are some of the clues we can use to determine the origin of sedimentary rocks? Okay. For this section, we'll talk a little bit about weathering, sediments, and the process of lithification, which is, of course, an important part of the overall rock cycle. Okay. So weathering can be broken down into two components, two parts: mechanical and chemical weathering. Mechanical weathering involves physically breaking up rock. And water, ice, and in some cases wind are excellent. They're the main three mechanisms to really physically crack or split rock apart. Ice is fairly efficient at this process, but it is not widespread across the surface of the earth. Water is a little less efficient than ice at breaking rocks apart or wearing them down, and it is more sort of widely spread across the surface of the earth. And then wind carries the least amount of power, the least amount of energy, so it tends to be present in many places that ice and water may not be present, but it's not quite as effective as abrading or rubbing rocks down and creating sediments. The other way in which we can approach this is through chemical weathering. And one of the common or simplest reactions, because these are all chemical reactions, would be the process of dissolution. You experience this if you were to put salt or sugar in water. Rock is going to dissolve in the same way. And there are other chemical reactions, some of which create or will create different kinds of minerals through the breakdown of, let's say, plagioclase feldspar or potassium feldspar, which you might have looked at in lab, and are definitely part of igneous rocks. They commonly break down into things like kaolinite, or they break down into micas. Okay? The end result of all this mechanical and chemical weathering is to produce sediments. And what you see here are loose grains. These are the most resistant types of minerals. They're tough. They have you notice they have kind of a glassy luster because most of this orange and yellow stuff is quartz. Okay. The black material here, these are things like pyrite or magnetite or maybe even hematite, and they're relatively resistant to weathering as well. Things you don't see in this slide, minerals you're not seeing here: feldspars, micas. Those types of minerals are not resistant, or as resistant, they're not as tough to both the mechanical and to the chemical processes, and so they've actually been sort of weathered out and left behind. So if you went to the beach, you might see something like this. Depending on the beach you went to, beach sand could be made from shells as well, so not just sand grains. Okay. The process of lithification is to take those loose grains, those loose sediments, and you have them out on the sidewalk, on the street. Soil is a kind of a form of this to some degree, and they're going to go through a process called lithification. Okay. So the first step in lithification is to deposit the sediments in some sort of ocean basin, okay, or shallow basin, as a series of layers. I'm doing some layers up here at the top, right? So they get deposited, and as each new layer gets deposited, so if this is layer 1 on the bottom, this is layer 10 just for sake of argument, on top. As layer 10 is being deposited, it's pushing down, gravity's pushing or pulling it down, and it's compacting the sediments. So what we see is that we go from a loose set of grains like this, as it's compacted, okay, to a tight set of grains like this. So we get deposition and burial. Those are two parts, deposition and burial. Compaction. Okay. As we compact it, it's sort of like a sponge. We squeeze out some of the materials that exist between the grains. And since most of these are deposited in water, not all, okay, but many of them deposited in water, we see water get squeezed out. We see a volume reduction. So H2O here is out of the rocks. And then what the final process is, as they get buried and pushed down into the earth, they get warmed up a little bit, not real hot, but maybe 50 degrees, 60 degrees, 80 degrees centigrade. Okay? And then we see this yellow stuff in here. This yellow stuff is cement. It's either one of two things. It's SiO2, okay? SiO2, which is quartz, or CaCO3. Okay? CaCO3 or SiO2, those are the two main types of cements. Okay? And that's actually what holds the rock together, is that cement. It's analogous to making concrete or bricks or something along those lines, right? Those are kind of artificial stone. Okay? The rocks themselves are going to be deposited in different types of depositional environments, and I'm going to come back to this over and over again through this chapter. What is a depositional environment? There are three main types of depositional environments with many sub-environments, and you just want to focus on these main three, and I'm going to highlight them here. Okay. So I'm going to draw a line right along here. Everything on the continent we're going to call continental. That would include glaciers, that would include lakes, sediments traveling or deposited in desert regions, anything to do with ice. Okay? Down here, we have something along the coast. I made a wide zone here. Okay? The coast is what we call transitional. It's transitional between continental and then the third one, which I have listed here, which is marine. So marine includes things like coral reefs, shelf deposits, slope deposits, deep ocean sediments. Okay, but there are many of these that are transitional, where you get, sometimes it's wet, sometimes it's dry, depending on the surface elevation of the ocean, depending on the tidal conditions, depending on wind and storm conditions. So transitional environments might include the delta, okay, beach, right along the shoreline. Those would be estuary or tidal flat, right, which is down here. Sorry about that. Okay, would be a transitional environment. Reef, that's a marine environment. Shelf or platform, that's marine. Slope, rise, and deep marine. Okay, those are all marine environments. Okay, so those are depositional environments. And then we're going to think more in depth about kind of what it is that tells us that certain rocks belong in certain environments. Okay? So next we'll move on to talk about and classify the different kinds of sedimentary rocks, and think about how they're connected to depositional environments.